All right, we're going to go ahead and get started now. Hello, everybody. Thanks for joining us today for our first webinar of 2020, barrier panels. What are they not, and what they mean for your safety procedures. Before we get started, a few housekeeping items. So you might have seen the welcome message that popped up. Audio controls are disabled, so although you can hear us, we cannot hear you. If you have questions, please use the chat or question pane in the GoToWebinar navigation on the right. Also in that navigation, you'll see some handouts in there. We have a video on barrier panels, as well as a brochure on safety procedures and a sell sheet on our barrier panels. So please go ahead and check those out. And without further ado, we're going to get started. So real quickly, HOFFMAN is one brand of multiple brands under the nVent brand. We are publicly traded on the New York Stock Exchange with the sign NVT, and our other brands include EFS, Aeroco, Caddy, Aeroflex, and then our thermal brands. HOFFMAN this year is actually celebrating 75 years of business. So we started back in 1945. And with that, we're actually going to do a quick little trivia question before we begin. So shortly a poll will be popping up on your screen. The question is, which of these products was not manufactured by nVent HOFFMAN in the early years? Is it the dandelion digger, the clay target or clay pigeon thrower, the handy whip mixer, the clean floor vacuum, or the clothesline hanger? So if you go ahead and go into the polls in the GoToWebinar navigation, you can go ahead and vote. We'll give you about 1 or 2 minutes here. So not to lean you in one way or the other, but I was leaning towards the clay target thrower because we came from the Federal Ammunition Company. I was thinking that was to kind of throw us off, but that's what I was thinking going.
Trick question. I happen to notice enclosures is not on that list.
A little odd, right?
These were all the obscure products that were part of the portfolio between 1945 and 1947.
Okay. All right, so I'm going to go ahead and close the poll here. It looks like we've got most of the responses in. We have a resounding 40% voting for the clean floor vacuum, and then 23% for the clothes hanger. And the correct answer is the clean floor vacuum. So congrats to those who got that one correct. And with that, I'm going to go ahead and introduce the other panelists that are in the room that you might have heard talking.
My name is James Swanson. I'm the Global Product Training Manager. Been with the company now since 1984.
Yeah, hi. I'm Glenn Campa. I am actually a regulatory engineer for HOFFMAN. I've been here for 21 years.
All right.
Glenn is also on the UL 508 and 508A board, as well as the UL 50 and 50E board. So don't let him undersell himself. Glenn is here as a resource for our question and answer at the end. So if you have questions, please propose those towards the end. So with that, I'd like to say hello and welcome to today's presentation, barrier panels, what they are, what they're not, and what they mean for your safety procedures. I'd like to start this presentation by saying this presentation is being given for the purpose of circulating information and opinion among those concerned for fire and electrical safety and related subjects. If you have questions, please refer to the reference standards for complete details. In today's presentation, we'll be looking at common misapplications and misconceptions. We'll look at proper applications, and we'll look at the benefits of utilizing barrier panels. So when we talk about what barrier panels are not, first thing I want to say is barrier panels are not arc flash containment. In the event of an arc flash incident, copper wire can vaporize, expanding up to 67,000 times. The resulting pressure wave would push out through the areas of least resistance. A barrier panel is considered an arc flash prevention method, preventing incidental contact with live electrical connections in an area beyond the panel. It will not contain an arc blast in the case of an arc flash incident. So I just want to be absolutely clear that it is not containment. Barrier panels are not flame containment. While the barrier panel does provide a physical separation between the bays, depending on the construction of the barrier panel, there may be small holes in the panel. And if there is fire in one of the bays, that fire may spread to another bay in the enclosure. So it's not total containment, it's just going to be deflection. Barrier panels are not necessarily sound reducing. While providing a physical barrier between the bays, this does not ensure sound reduction. Because most barrier panels are constructed from conductive metal, they may decrease sound, or they may have the adverse effect and resonate and amplify sound. Think of it in terms of a piano soundboard, a solid surface that amplifies sound instead of reducing it. I've also heard of instances where industrial air conditioners were installed on a cabinet and the decibel level actually increased above the level of the sound pressure that was produced by the air conditioner alone. Every application will be different dependent on the components producing noise inside the cabinet, so you'll have to take a look at each and every cabinet individually. The other thing that barrier panels are not is they are not EMI RFI barriers. To be an EMI RFI barrier, there would need to be a continuous bond around the holes, metal to metal, of surfaces bonding together. With any openings that may occur between the compartments, they need to be isolated by mesh. The picture on the right-hand side here is greatly exploded so that you can actually see that mesh underneath there. Even the gaskets need to be completely bonded. These are just a couple of the requirements. For complete requirements, please consult the proper standards. But the point I'm trying to make here is that barrier panels are not EMI RFI barriers. Especially when you see some of the illustrations of the barrier panels that we have, you will see that there are actually small holes in them. So what barrier panels are voltage separation, power source separation, and arc flash prevention. It's a simple solution to help reduce the risk of electrical hazards, such as electric shock or arc flash, by adding that physical barrier inside the enclosure, oftentimes used to separate high voltage and low voltage compartments. But in the case of power source separation, if you had multiple bays and you had power coming into say the bay on the far left and the bay on the far right, you could have different power sources coming in utilizing some kind of a through-the-door circuit breaker or through-the-door fuse holder that would allow you to have power in different bays of the enclosure. The most widely recognized benefit of utilizing barrier panels is going to be creating that Type 1 barrier panel. The creation of a Type 1 internal enclosure helps you with arc flash prevention, and we'll talk about how that complies with NFPA 70E. There is a big push for worker safety because of the OSHA Code 1910 Subpart S. Arc flash safety is a, quote, recognized hazard, unquote, and thus holds severe consequences for employers who have not implemented safety measures. If an arc flash incident were to occur, employers would be held to that NFPA 70E standard, even though it's not enforced in the effect that there were not an occurrence. As a result, there's a push towards higher voltage components being isolated and lower voltage components that fall within the low voltage directive, components that are below 50 volts being isolated on the other side. To achieve that control, newer panel designs are incorporating more safety features, including low voltage compartments. And with a barrier panel properly installed, a multi-bay enclosure can now have a high voltage and a low voltage compartment. In this illustration, the bay on the right closest to the power, closest to the disconnect, the high power disconnect, would typically be the high voltage bay, while the one farther away would be the low voltage compartment. And this is where a barrier panel would be installed inside the cabinet. To give you a little better view of that there, I've got some oblique angles so that you can see where the barrier panel is installed inside the control enclosure. All right. So one of the advantages I talked about was having a Type 1 barrier panel. With your barrier panel properly installed in the control enclosure, the enclosure can be separated into multiple Type 1 enclosures if you are using a Type 1 rated barrier panel. If the barrier panel being utilized is not a UL Type 1 rated panel, the installation will not be separated into Type 1 panels when the doors are open. So you need to have a Type 1 rated panel to get the benefits that I'm about to talk about. To be a Type 1 rated panel, the panel would need to pass the probe test when installed. Illustrated is the articulated UL probe. To oversimplify it, if the probe can reach any surfaces that electrical components will be mounted to, it fails the test. To demonstrate the value of the Type 1 rated barrier panel, if one door of the enclosure were to be opened, say the one that's open in this illustration, the other bay of the enclosure would remain an enclosed UL Type 1 enclosure. If the first door were closed and the other door of the enclosure were to be open, the other bay of the enclosure with the door closed would remain a UL Type 1 enclosure. So as long as the door is closed and all of your surfaces are completely enclosed, it will remain a Type 1 enclosure. With a UL Type 1 barrier panel installed, there will be 3 distinct enclosures to be rated in this illustration. Once an IEEE 1584 assessment of control enclosures has been completed, the enclosures will be labeled with the appropriate hazard warning label. Then the appropriate PPE required for the hazard in each enclosure is established. Here's an example of the label that complies with the NEC requirements. There is not a standardized format for these labels as to where information to be located on the labels, but there is a requirement around the information included on the label. Information that's required, number 1 is nominal voltage. Number 2 is the available fault current at the service overcurrent protective device. Number 3 is the clearing time of the service overcurrent protective device based on the available fault current at the service equipment. And number 4 is the date the label was applied. So we need to know how long it's been on there, because sometimes things have been on there for a long time and the machine got moved. You do have to do a new assessment per IEEE 1584. So to repeat, once an IEEE 1584 assessment of control cabinets has been completed, the proper labeling has been put in place, and the proper PPE required based on the hazard of the enclosure is established, we look to NFPA 70E. Remember, NFPA 70E is an employee workplace standard. According to NFPA 70E 130.2.A Section 3, operating less than 50 volts, energized electrical conductors and circuit parts that operate at less than 50 volts shall not be required to be de-energized where the capacity of the source and any overcurrent protection between the energy source and the worker are considered, and it is determined that there will be no increased exposure to electrical burns or to explosion due to electric arcs. What this means is that an enclosure operating under 50 volts and under 1.2 calories per square centimeter, there is no level of PPE that is required. Now, while that is the requirement at Hoffman, we practice a higher level of safety for everyone involved, And anyone who is authorized to enter control cabinets is issued Category 2 fire-resistant uniforms and is required to wear them daily. Pictured is a Category 2 clothing with safety glasses instead of the face shield. At voltages equal to or greater than 50 volts, the PPE level spelled out on the warning label is required. With the sequester enclosure attached to the control enclosure, the highest level of PPE will be required in the sequester enclosure itself, and the enclosure being fed by the sequester enclosure will have a lower level of PPE required, depending on whether or not the calories of the energy are significantly less than what's in the sequester. With both control enclosure doors open, the PPE required will be based on the warning label of the highest rated enclosure door that is opened. I'm moving through this a lot faster than I thought I would, but that's all right. One note I want to touch on is grounding. All barrier panels will need to be bonded to the main equipment grounding circuit per UL 467. One of the things that you will notice here is we have bonding straps on certain panels. Other panels are bonded through the screws, and that is where the bonding is actually happening on those particular parts of the panel. So the HOFFMAN Universal Barrier Panel is a simple solution to help reduce the risk of electrical hazards such as electrical shock and arc flash by adding a Type 1 rated physical barrier inside the enclosure so that we can separate the high voltage and the low voltage components as well as multi-voltage enclosures. This will help us reduce the risk of electric shock and arc flash during routine maintenance. By separating the high voltage and low voltage when the power is on. It gives us full depth separation, and that's one of the things that we have with the Type 1 enclosure barrier panel. We have that full depth separation, both top and bottom as well as front to back. So with the UL Type 1 rated enclosure, we have UL Type 1 rated compartments requiring separate PPE levels. And we all know that the lower the level of PPE that's required, the more likely the maintenance guys are to wear it. These are also going to be IP20 finger safe. So really briefly, HOFFMAN has multiple enclosures that are designed to work with our universal barrier panels. In mild steel, we've got our A21s, our A28M2s, and A28MMs, as well as the A4L3Ds, and the A4L3s, and the A4Ls. And stainless steel, we have the A21S4s, the A28S4s, the A4S2s, the A4 S3s, and the A4SLs. Some of these panels are going to have, some of these panels are set up with interlocks already. Others of them are not. So who's going to benefit from this? Anyone who has control enclosures, it can benefit from it, from automotive to material handling, to petrochemical. It's everywhere that we want to reduce the risk to employees by preventing arc flash on existing 70E or prevention by design at your organization. This is for you. This can help you design out arc flash incidents by lowering the voltage in new equipment. And heaven forbid you've been fined for not complying with OSHA standards, but that's another place where this would be very relevant to you. And have you had issues with competitive barrier solutions? Again, as I mentioned before, if it is not a Type 1 rated barrier solution, you do not get the benefits of a type 1 rated enclosure when you open one of the other doors.